Well, this is certainly an excellent question from a previous chapter. It says, write the equation of the exponential function in the form y equals a b to the x, passing through these two given points, and then sketch a graph of the function. Um, so, when you look at it, our strategy has been, well, there's two ways we can do this, right? I'll do this point in red, and I'll do this point in blue. But take a look at it. I'm going to write two different equations that are in this form, right? Plugging in the x and the y from the red and the blue. So let's do the red first. The y value there was 3.84, and that equals a times b to the second power. So our strategy here is to figure out what a and b are. Once we know a, our zeroth term, and b, our multiplier, we can easily write down the equation. So same thing for the blue one. We've got y, which is 3.072 equals a times b to the third power. Okay, so what we've been doing is isolating a in one of the equations and then plugging into the other, the second equation. So I'm going to isolate a in this first equation, and it's just one step, right? I'm just going to divide both sides. Well, let me do this, be consistent, use the red here. I'm going to divide both sides by b squared. And when I divide by b squared, you can see clearly I created this giant one, so I'm left with just a. So this thing right here, the 3.84 over b squared, is equivalent to a, and I'm going to plug that into the second equation. So when I make that substitution, I get 3.072 equals a, which is 3.84 over b squared. And then I'm going to multiply that by b to the third power. And I'm going to write it as b to the third power over 1 so I understand exactly what's happening. So if you take a look at that, I've got a b cubed in my numerator and a b cubed in the denominator. That simplifies to simply b. If that's a mystery to you, you can always, just practice this and write bbb over bb, and you can see it cancels and you're left with just a factor of b. So if I simplify this, I have 3.072 equals 3.84 times b. What great luck. This is going to be easy to find out what b is. I'm just going to grab my calculator here and I'm going to multiply 3.072. Well, I'm going to divide that actually, divided by 3.84. And when I do that, I get that 0.8, was it 0.8 or 0.08? 0.8. 0.8 is B, so I know my multiplier. I'm multiplying by 0.8 each time. Now I just need to figure out what my zeroth term is, and there's two equations I can use to figure that out. But what I'm going to do is I'm just going to take this value of B and plug it into this expression. So I'm going to get 3.84 and divide that by this 0.8 to the second power, and that will give me exactly A. Let's see if I can do that with the calculator. It's in standard form. I'm going to go to scientific here. So I'm going to take 3.84 divided by 0.8 raised to the second power. Interesting. And that equals 6. Who knew? So A, our zeroth term, is 6. That means the equation of this this exponential curve is y equals 6, that's my zeroth term, times 0.8 to the x power. Now, as lovely as that is, and as much as I hope I'm correct, right? I'm really not correct, and well, like I am correct, but I should probably check it. So what I can do is grab this calculator here, and if I take my x value of 2 and I plug it into this equation, right, it should produce this value of 3.84, right? When x is 2, I should get 3.84. And when x is 3, I should get 3.072. So I just want to verify that. So I'm going to go ahead and go 6 times 0.8 squared, and that better give me, and it does, 3.84. That's happiness. And if I take the 6 times 0.8 and I raise that to the third power, it should give me, and it does, 3.072, which is fabulous. An alternate approach, especially when you see your x values are next door neighbors, this thing that I did always works, right? It's not always as convenient, and sometimes you have to take like the fifth root or some weird root of b. But when x values are neighbors like they are here, you might consider making a table of values as another representation. You can look at the 0, 1, 2, 3, 4, 5, etc. And then over here for my y values, I don't know what y is when x is 0, and I don't know what it is when it's 1. But when x is 2, I know that it has to be 3.84. When x is 3, I know that it has to be 3.072. Now, why that's nice is just looking at that, I know I can figure out my multiplier, right? If I take this number, the 3.072, and divide it by 3.84, I'll understand what I multiplied 3.84 by to move forward. So let's take the second number, 3.072, and divide that by 3.84. And you can see that I get 8/10, right? So as I move forward here, I'm multiplying by 0.8 each time. And I could extend this list by continuing to multiply by 0.8. Now, if I want to go backwards 2 steps to figure out what my 0th term is, all I need to do is divide by 0.8 twice. And I'm going to do that. So I'll take 3.84 and I'll divide that by 0.8. I get this number, and I'll divide that by 0.8 and I get the number 6. Fabulous. So I know that this is 6 and this has to be 4.8. So this is an alternate way to do it, right? I can see that my multiplier is 0.8 and I can figure out my 0th term is 6. So you can see my equation is still y equals 6 times 0.8 to the x. Definitely something to spend some time on thinking about and really studying to understand this. You'll see many more questions like this, and you've seen quite a few like it already. But that's enough.